welcome to my session here at DevOpsDays Tel Aviv. I'm super excited to be here, and today I'll be talking about how DevOps can empower developers to troubleshoot Kubernetes independently. Okay. This is actually my first time presenting, so please be kind. Before we get started, I would be happy to introduce myself. Yeah. Okay. My name is Rona Hirsch. I'm a software developer and a DevOps engineer at Commodore. We're a small startup that's been creating a lot of buzz over the past year and a half now. We're actually building the first Kubernetes native troubleshooting platform, which helps both developers and ops teams to troubleshoot Kubernetes efficiently and in a more empowered way. Prior to this, I worked as a DevOps engineer for 5 years, developing and automating DevOps processes. If you ask me, I'm very passionate about Kubernetes and automation. Otherwise, I wouldn't be working at Commodore right now. And specifically, I'm very passionate about this topic, and I hope you find some of the insights and best practices that I'm about to share very useful and interesting. So without further ado, let's get started. Essentially, I want to take you into a story, or more like a scene maybe. So imagine that right now, it's 3:20 in the morning. It's probably dark out and not light the way it is right now. And suddenly you hear this PagerDuty alert, and unfortunately you're on call. And that means that you have to immediately wake up, go out of bed, and start investigating what the hell happened. Now, there are maybe two possible scenarios here. The first one is that it's a pretty straightforward problem and solution. You find out what is the issue in like 2 minutes, you fix it right away, you go back to sleep, and everything is good. The second option is not that pretty, where it takes you the whole night to troubleshoot, trying to figure out what is the issue, and only after 4 hours you find out what is the problem, you fix it, and you have no time left to sleep. So, which one would you prefer? The 2 minutes troubleshooting process or the very, very long 4 hours? The bottom line here is that troubleshooting Kubernetes can be very complex. That's the bottom line here. And why is that exactly? Well, there are a few reasons for it. Let's dive into them. So first of all, there are a lot of blind spots, right? I mean, changes are often unaudited or done manually, and you can't really tell who did what or when. On top of that, your data is fragmented all over the place, right? Each person's tech stack here is different, but if we go back to our PagerDuty alert, what you'll do is you will go and look at your login solution, your monitoring solution, your CI/CD, your repos, your feature flags, and so on. You'll try to connect the dots and make sense of it all, and that's not easy. And always, there's the butterfly effect, that in the end of the day, one minor change in one service can affect other services dramatically, and you can't really pinpoint where it's coming from. Now, Kubernetes complexity also comes in terms of lack of knowledge. If you look at your R&D teams, you'll see that not everyone has the same amount of knowledge. Some are maybe experts, some have more expertise, some are maybe beginners or have never even worked with Kubernetes before. There's a lot of gaps there. And also, there's always the issue of lacking permissions and access. People often complain that they don't have access, and how can you troubleshoot efficiently if you do not have the required access? And what happens if you do have access, but you're lacking the Kubernetes knowledge? What do you do then? Can you troubleshoot efficiently? Probably not. And that brings me to the whole or main point of this presentation. How can DevOps simplify Kubernetes troubleshooting and for developers, and how can we bridge the gap between them? So I'll be giving you 5 best practices to help simplify the day-to-day troubleshooting process. I'll start with the most important one maybe, and that's monitoring. So basically, if you don't monitor your system, you really don't have anything, right? You can't troubleshoot, you can't do anything. So as a side note, if you haven't picked a monitoring solution yet, just now is the time to do that. There are a lot of options from open source projects to managed ones. So just do your research and pick one based on your level of expertise and your requirements. Okay, so now that we all have a monitoring solution, we need to start thinking about continuous monitoring. And that means you do not want to monitor only your production environment. You always want to monitor all your environments. That will give better insights to you and your devs about what's going on in your system and how frequent code changes are affecting your environment. Next, it's maybe basic, but a lot of companies nowadays run on cloud environments and are using their managed services. And it's really, really important to monitor them all because you want to know if your pods are crashing because Elasticsearch is low on disk space and you need to add more nodes to it, or if your messages are stuck in a queue, for example, and maybe you need to add more replicas to your service in order to handle them. So pay attention to that and just monitor them all. Next, what's really important is to choose the right matrix for you. And what does that mean? What do I mean by right matrix? It means don't just monitor something because everyone else is monitoring it, or because it maybe sounds sexy to monitor latency, for example, but you don't really know what that means and you don't really know how it helps you. Monitor things based on your business logic and things that make sense to you and your product. That will decrease the level of noise that you have, and noise is something that we really want to avoid, because eventually, if you and your devs are having a lot of noise, what you'll end up doing maybe is muting your Slack channel, and then you'll just miss all the relevant alerts. Yeah, so don't do that. And next, my next point ties up really nicely with Matrix, and that's dashboards, and specifically building useful dashboard. So what is a useful dashboard? Is a useful dashboard the one that contains a lot of graphs inside and has a lot of information? Or is a useful one a one that contains less graphs, but each one of them is precise, and you know that once it fluctuates or spikes, something is wrong in your system. So think about the dashboards that you're using and let your devs know how to use them, what are their purpose, and just give them all the information. And last but not least is don't keep the monitoring task till the end. We always tend to do that, and until it really blows up in our face, because now something is not working, production is down, and everyone is asking, why aren't you monitoring this? And then you remember to take the task out of the backlog and do it. So just build a strong foundation from the get-go. It will save you a lot of money and time in the future. Okay. Moving on to another important subject that is closely related to monitoring, and that's logging. So logging, as many of you know, is a really good tool for troubleshooting different things into your apps. When talking about logging in Kubernetes landscape, you don't need to give all your devs access to kubectl or production clusters. You can use logging in a controlled environment where different people have different access, so you don't need to set up crazy RBAC or permissions on Kubernetes to make that happen. So my first tip here would be to centralize all your logs into one location and manage dev access from there. My second tip will be to optimize your logs by tagging and labeling them. It can be as easy as the service which is currently logging, the version you're running, some cluster information such as which node are you running on, which environment, the cluster name maybe, and always business-specific data, such as which account is currently making the request or which client, and so on. Essentially, everything that applies to you when troubleshooting. Let me give you a small example from our actual logs at Commodore. You'll see here that we've added a lot of metadata to our logs, including some of the things that I've now mentioned. That really helps us when troubleshooting, because we can just filter out the relevant logs pretty quickly and easily, and we don't need to waste a lot of time going through irrelevant logs. Now, we can't really talk about Kubernetes without talking about YAML file. So, Kubernetes is based on YAML files. With them, we actually describe the desired state of our cluster or resources, if you will. So for example, if I want to deploy a new application, I would just write a YAML file. I would specify which Docker image I want to use, how many replicas do I want, the configuration, and so on. Now, for those of you who worked with YAML file before, you know that they can be hideous. But we can use them to our advantage when troubleshooting. How do we do that? If we look at the example here at the top at the label section, we'll see that the same with login, there's just a lot of metadata here. Everything is listed, such as the team, the DB, the version, even the Git commit. So using labels and annotations can really help you when troubleshooting. On top of that, what can really help to know when something is wrong is using environment variables, config maps, and secrets. Let's talk for a second about environment variables and config maps. So config maps are basically key value pairs in Kubernetes. What a lot of companies do is just plain text list the environment variables inside the YAML file. And then when trying to separate environments, such as production and staging or staging and dev, they just copy paste the app and the YAML file, call the other one staging, for example. And that really creates a problem because it's hard to track pod spec changes. And what I would suggest is just taking out all the environment variables out of the YAML file, store them inside a config map, and then you'll just have two sets of config maps and one YAML file to keep track of. And the last thing I'll say about YAML files is probes usage. So probes is probably one of the most basic concepts of Kubernetes, and if you define and use them correctly, it can make it a lot more enjoyable to use Kubernetes. So the liveness and readiness probes actually tell your cluster if your service is, one, ready to receive any requests or traffic, and two, if it's now alive and can continue receiving the requests. If it doesn't, the probes will fail and Kubernetes will just tell your service to restart. So I think that what I've mentioned here in this section is really important when defining YAML files. You can encourage your devs to keep up with these standards and write better, clearer, and more useful for troubleshooting YAML files. Now, I want to talk a bit about stateless versus stateful applications. For those of you who don't know, Kubernetes was built for stateless applications. It is based on the premise that everything should be volatile and don't worry about persistency. I think it's a lot easier to write stateless applications. You don't ever need to fear of any loss of data or data corruption. When building stateful applications, you'll always be in fear of what happens if, for example, now you need to scale up your service and add 5 more replicas to it. Are you using some kind of persistency or volumes? Do you have to spin up more volumes to use? What about your service? Can it handle it now that it has 10 instances of it instead of 5? Is it synchronized? When building stateless applications, you can just do whatever you want. You can scale up thousands of replicas, and you'll be fine. So what I'll say here is encourage your devs to write stateless applications, but if you are using stateful applications, in a lot of cases, just let the devs know what it means to run a stateful applications on Kubernetes, what they should be expecting, what are the common errors, etc. That really goes a long way when troubleshooting. My next and final topic here will be separating environments. So I would always suggest to keep dev and production environments separated and not on the same cluster. Just think about when you're getting an alert from dev, it's usually not a big deal. But when you're getting an alert from production, it's like, oh my gosh, I had to fix it right away, right? So just keep the two apart, and in my opinion, always keep the production environment isolated. So how do we do that? We have two options. One is using separate clusters or even separate accounts. Kubernetes does a really good job at managing different clusters and contexts. But there's always the issue of cost. So another option is using namespaces. Namespaces are a mechanism for separating groups of resources within a single cluster. So it's a really common way to segregate environments. You can choose whichever option is good for you, and it will be fine. Okay. The best practices that I've shared with you today are really the foundation at the end of the day of what I think is needed in order to make the troubleshooting experience for developers a bit more easy and intuitive. But let's not forget that it's not only these best practices that count, it's also the enablement work that you do with them, getting the buy-in on the solution that you're choosing, training them on the tools that you're using, and iterating best practices together with them in terms of how to troubleshoot efficiently, etc., really goes a long way. And these two factors of these best practices, plus together the joint work and enablement that you do with them, is the secret sauce for making the troubleshooting experience for developers very good and confident and easy. And with that, I'd like to thank you all for listening to this session today. Just before you go, my awesome company, Commodore, is running a daily raffle here at DevOpsDays Tel Aviv. So if you're feeling lucky today, please make sure to sign up and stand a chance to win a $500 flight gift voucher or an amazing limited edition Dune t-shirt. You can see my fellow Commodorians walking around the Floor Expo because they are wearing these awesome t-shirts. So best of luck and have a great day.